So today, this session, I will talk about analyzing StackExchange with Azure Data Lake. So first, I'm Tom Kerkhove. I'm from Belgium. I'm an Azure consultant at Codit, which is a company in Europe. I'm based in Belgium. So I'm also an Azure MVP and an advisor, and I'm part of the Azure user group in Belgium. I wrote a little white paper on the Internet of Things. If you're interested, you can find it over there. So what's on the agenda? First, a quick introduction to Azure Data Lake, and then we'll dive into what is Azure Data Lake Store and analytics. And then I'll use the StackExchange to show you how you can combine them and how easy it is for me as a developer, not a data scientist, to write queries that will run on larger data sets. So first, big data. It's a big buzzword. And if you start looking into it, you have Hadoop with all these other kind of technologies, which are open source, and it's a rapidly evolving ecosystem. So first, the no-brainer would be let's go open source and use these components. But as a C# and SQL developer, working with the Microsoft stack, that brings a couple of challenges. So the first is most of them support SQL-like languages, but not the T-SQL language we're used to. And also the custom code, well, there's no C# support. So I need to learn a new language, need to maintain that language as well. So it's another challenge. It's rapidly evolving, and also I need to spin up clusters, operate those clusters, need to know how to set them up. It's also an extra burden that I, as a developer, don't want. Last but not least, it's typically with Linux, which is also not something a lot of Microsoft developers use. As of today, it's evolving more towards Linux as well, but not everybody's used to it. So it's yet another hurdle to jump. So Microsoft has an alternative. So they have what's called Azure Data Lake, which is a kind of umbrella of 3 services. On the left, you have Data Lake Store, which is a web HDFS data store, where basically there's no size limitations. You can put whatever data in it that you want. Then you have Data Lake Analytics, which is an analytics job service where I can just write scripts, give it to Data Lake Analytics, and they'll run it for me. I don't need to provision anything. And then last but not least, you have HD Insight, where you can provision those open source technologies if you want on a cluster. So this is what was available before, where you still have to maintain the cluster, set it up, operate it, and you use the open source. But for me, it's a big jump to go to big data. So let's dive into the details. So Data Lake Store, like I said, is built on web HDFS compatible, and it can store any sizes of the files, and it has no limitation on the total size. So it's basically an infinite storage, if you will, but you know, infinite doesn't exist. You can also store any format. It's a schemaless data store, so you don't need to define the schema up front, just store the files. And it's a write once and read many principle. So it's optimized for running analytics jobs on top of it. It also has enterprise-grade security, which we'll see later. It's built on Azure AD, so not on fancy authentication keys, just using the security we already have. So it's basically the big data store in Azure if you don't want to run your own cluster. So it's fairly easy. And as you can see, it's the center of your big data ecosystem. If you are working with the cloud, where on the left side you have all these other services which you can use to ingest the data. On top, you can have multiple services to process the data. So we'll use Azure Data Lake Analytics. Then you can visualize it with other services, where we will use Power BI. And then on the right, you can also download it or move it to another data store if you need. So basically, it's all built around Data Lake Store. A small caveat, what is a data lake and how does it compare with the data warehouse? Because it's not the same. A data warehouse is typically a warehouse which is also a central place to store your data, but it's a central place with structured data. So this means that you need to define the schema of your data up front, and you need to create those extract, transform, and load pipelines to make sure that the data is in the format that is required. So it's been around for a while. A lot of companies use this. And then on the other side, you have a data lake where you just basically dump all the data in the raw format in the data lake itself. This can be unstructured, structured, and semi-structured. And you don't need to define any schema. Okay? And then the data scientists just go in the data lake and select the data they are interested in, check what's the schema, and then process it. This has the advantage that you don't get rid of certain data attributes when you're storing it, because with the data warehouse you need to define the schema, and it can happen that as of today you don't need a certain data field, but in 2 years you might. But since you had to transform the data set, you already lost all that information, so you can't use it anymore. But the downside of a data lake is, since it doesn't have any structure by nature, it can be a data swamp, which is not nice. So if we see this picture of Martin Fowler, which wrote a very nice article about this, you can see on the left the data warehouse where you basically clean the data before you store it, and then the analysis is done based on that schema. So basically you prepare the data for the analysts, where on the right you have the data lake, where you just have everything in one big data store, and they just transform the data they need for their reports, visualizations, or whatsoever. You can basically compare it with fishing, where on the left, if you want to eat a trout, you go to the data warehouse and you buy the trout, it's already prepared and everything. While on the right, you can still go fishing in the data lake, where you can select the fish you want and cook it how you want and prepare it how you want. But if the lake is full and you create a data swamp, your fish will die and the data will be useless. It's a small comparison you can make. So security for data lake store, you can use role-based access control for the store itself, and you can grant users and group access to certain folders or files. So you can really lock down who has access to what and really control this. It also has a firewall, which is off by default, unfortunately, but this allows you to really protect your data set from the inside and only allow the certain IP addresses to get access to it. And you can also add encryption at rest, where either Microsoft controls the keys or you provide your own with Azure Key Vault. Okay, and pricing, yeah, here's a big overview, but basically you use a pay-as-you-go model, or you use a monthly commitment package, which makes it up to 33% cheaper, but then you need to pay those packages. You basically pay per transaction for read and write, and as you can see, read is cheaper. Why? Because it's built for analytics, and they want to motivate you to less frequently write to the data store. Okay, and then a small comparison with Azure Blob Storage, because you can use that as well. You can see that while Data Lake Store doesn't have any limitations, Azure Storage has them. They're very big, so I think you can have up to 100 accounts per subscription, up to hundreds of terabytes, so it's also very big. But you need to separate them across blob storages. Then security, it has the AD support, like I mentioned, while in blob storage you need to use SAS tokens, which is less secure. But the pricing for Data Lake Store is more expensive. I think the only storage option that is more expensive is globally redundant storage with read access, so that's the most expensive one. Redundancy is a different topic, because data lake store, you don't have access, you don't control how redundant it is. I think it's only locally redundant. So if one region goes down, you currently lose your data, which is not really nice. While with blob storage, you can basically control it locally, zone, geo, read access. Scalability, well, Data Lake Store is built for analytics, so it's really optimized for reads, less for writes, while blob storage basically is built for the two. And they both have integration with Data Factory, Data Catalog, and HD Insight. So from that perspective, there's the same. Okay, we're almost through the introduction. Data Lake Analytics is the most interesting one to me, because you basically have a serverless kind of analytic service where you write the jobs, you write the scripts, you give it to the service interprets them, optimizes them, shares them across multiple nodes, and they run it all for you. You basically just give them the script. And to do that, you can use U-SQL, which is a mix of T-SQL language and C# language. So basically I can just write T-SQL scripts. If I need to have some extensibility, I can just use my C# scripts. You provision a certain amount of analytics units once you submit the job, which basically defines how many nodes you want. And then you pay per processing time per analytics unit. So the more units you use, the faster the job will be completed, but you will pay a lot more, which makes sense. But we'll see that later on. So basically you have these kinds of data stores that are supported. So Data Lake Store, obviously, which is also a required one because they store metadata for the jobs. And then you can also use blob storage for query and write, and then any kind of SQL data store in Azure for reads. And Data Lake Analytics also has built-in partition tables if you need those, which can come in very handy. So basically you just use the correct data store you want. If you, for example, have a lot of telemetry data in Data Lake, but you need to correlate them with a different data set which is in another database, you can just do that as well. You're not limited to Data Lake Store. And then this is an example of a U-SQL script where at the top you basically extract the data from a data set, where you also define the schema of that data set. So this is where you need to do it, not when you ingest the data, but once you want to extract it. And you could say, I want to use CSV, TSV, or you can write your own, which we will do. And then you can just transform and analyze the data how you want using SQL syntax inline, for example, over here, or over here. Or you can also use method calls. It's however you want. And then at the bottom, you basically output the result of your script to another location. So here it is a Data Lake Store, but you can also do it to blob storage, and then you can order by or whatever. And then you can choose how you want to output it. Here it's with the CSV, but again, you can use TSV or create your own outputter. So this is a very basic example script, but you can really go as crazy as you want. But this is the way you need to do it. Basically extract, transform, analyze, and output it. So extensibility, like I said, you can use inline C#, or you can create those custom-defined functions, operators, and aggregators, depending on your scenario. And those operators are also a couple of them. So we will create our own extractor to extract it from the data store. Then you can have processors, reducers, combiners, appliers, and outputters, all with their own use case, but they all come in handy. This is a big overview of the metadata model. I won't go in detail because of the time, but you can basically see that you have an Azure Data Lake Analytics catalog, which is your instance in Azure, under which you can have multiple databases. Basically, like you have with the database server, you can also have multiple databases and then limit who has access to which database. And then under there, you have also data sources that are linked, schemas, tables, etc. And also C# assemblies that can be used in the scripts for that extensibility. Okay, if you provision a U-SQL script, it's basically compiled, and then they define how the processing should look like. Then they optimize the script for you by creating the optimized plan. They use the job scheduler to queue the job for you. Then the job manager will divide the work across multiple vertices. So that's basically your data set, which they divide in smaller pieces. And then they will just distribute it across all the nodes. Once they are all completed, they will come back to the job manager, and then your job is finished, and the output is in Data Lake store. If you want to have a more detailed overview of this, Michael Rice did a very good presentation on tuning and optimizing U-SQL scripts, where he goes more into depth on this topic. So if you have more advanced scripts, this is really useful to have. Okay, and this is an example of how you can write a simple script and how they optimize it into all these pieces for you, and you don't need to know how it all works. Just submit it and they do the magic for you. Then you can see all the states of a job. Basically, you create a new one where they compile the script, they queue it, and they schedule it, and it starts processing, then it runs in, and it ends. So you can all follow this along in the tooling. So almost there. Security, we also have RBAC support, so you can support the instance in Azure, where you can select who can manage the instance itself. It also has a firewall, and you can also have access control on the catalog or the database, like I mentioned. So you can lock down one database for user A, while user B only has access to the other one. And you can also use resource management, because it's not that cheap. You can also make sure that if somebody new starts, they don't provision 100 analytics units while they only need 10. So you can use these groups where you can say, okay, these new developers can only provision 5 analytics units, while if it's for production, we want to have more analytics units and a higher priority in the job service. And then on an account level, you can also assign the maximum analytics units, maximum concurrent jobs, and how long the metadata of the job should be available. And for pricing, you basically pay 28 pennies per minute of an analytics unit, which is not that much. But like I said, the more you assign, the more expensive it gets, and it's not because you assign more units that the script will be faster. It all depends on how the script works. The tooling also provides an optimizer where you can see, okay, I've provisioned 20 analytics units, but basically the service only used 10. So if I submit it again, we maybe should optimize to 10 units because we overpaid for 10 units. And here we also have the monthly commitment packages. Okay, a lot of talk, so let's show it in action. So what we will do is StackExchange has over 280 websites, including the meta websites, of which they have 150 gigabytes of data they publish. So we'll use that data set as an example, where we will get the data by downloading it. I actually already did that because we also need to extract the zip files, upload those in Data Lake. So I did that already, but I'll show you the script I used. It's fairly easy. And then once it's there, we will start merging all the data sets for each website into an aggregated file. And then based on that aggregated file, we will try to determine how many people filled in the location on their profile, which actually matches to a country. And then we will visualize that in Power BI. So this is a small setup of what we used. So we have archive.org, which is the website where they publish this. So I provisioned a VM in North Europe, where I download all the zip files. I extract them on an SSD of 1 terabyte. So I had a lot of XML files then. Then I used the PowerShell script to upload it to Data Lake Store. Then I used 2 scripts to aggregate them and run the business logic on top of it. And then Power BI uses the data of Data Lake Store. Okay, so let's dive into it. First, this is the website for those that are interested. It's archive.org, but somehow this thing is in front of it, where you basically have every, I think it's 6 months, a new data set of all the data. And if you have a look, they basically have 1 zip file per website, except for StackExchange because it's way too big. So if you have a look over here, you can see, for example, this guy, all the posts on Stack Overflow is 18 gigabytes in a compressed version. So it's not that small. So what did I do? I wrote a small PowerShell script which basically authenticates with Azure AD, with Azure Resource Manager, sorry. Yes? How do you do in a Visual Studio Code? No, it doesn't work on code. Ah, yes, it does, sorry. Okay, so first we will authenticate and assign the subscription we want, which basically just authenticates with Azure Resource Manager, and then it will just use the Azure Data Lake Store commandlets to say, okay, sorry, wrong script. That was to download, because I actually had to move one from a data lake to another data lake. So I first had to download it. Okay, the correct script. So basically I just authenticate and then I want to upload them all. So what I did was I specified the data lake store account name, the local folder on my VM, and then the destination folder on my data lake, which was basically the root. So if we have a look, I basically just clean up the parameters first, and then for each file I just loop over all the folders, then remove slashes because Data Lake doesn't like them, and then we start uploading. So if it's a folder, I just check, okay, does it already exist? If it doesn't, I just create a new Azure RM Data Lake store item where I say, okay, it's a folder and this is the destination. If it isn't, then I just do an import of an item where I say, okay, this is the account again, this is the path to my file, this is where it should end up, and then I force it. That's all I had to do. So basically just iterate over all the files. If it's a folder, create the folder in Data Lake. If it's not, just import the file. That's all I had to do. Then you can see I imported 3 data sets, which result in 620 gigabytes. And if I go over here, you can see I have 3 data lake store accounts, where the last one contains all my StackExchange data. And actually, if I have a look at that one, you can see that there's a data explorer where you can basically just browse the whole data store and download all the files, get previews, etc. So here you can see all the websites, etc. I can, if somebody needs to get access, I can do it over here. Okay, so this is the data set we will be working on. So for this, we need to create a new Data Lake store account to publish our result for Power BI. because I don't want to use the other one. So you just give it a name, for example, NDC demo. You use the resource group. That's better. Assign a resource group. The region I want to do, and then you can select the encryption settings. So either I can choose Data Lake Store or Key Vault. And because I like Key Vault more, I just then select the key vault I want to use. I select the encryption key, so let's use this one. I select the encryption key I want to use. And then I hit OK. But because it takes a while, I'm going to skip this and use this one, for example. And once you provision it, it gives me this warning. Why? Because Azure Key Vault is using Azure AD as an authentication mechanism. And basically over here, I first need to say, OK, this Data Lake Store account, I grant this access to my Azure Key Vault. So over here you can see my vault, my subscription, and the key I want to use. And then you basically grant the permissions. Okay, but I'm not going to do that because I already have one over here. And as I mentioned, it has a firewall which is off by default. So this is something I would typically turn on, but for the sake of the demo, we don't care. For the rest, there's nothing really fancy in here. We have a data explorer that I showed. We have some metrics which we saw on the dashboard, and that's basically it. So no alerts. That's it. So if you need to operate this, the only thing you have is an overview of the amount of data. Okay. So aggregating the data. Our data is in Data Lake. We can now start creating a U-SQL script that will run on top of all these websites, and that will output the result set in this Data Lake store. For that, we need a Data Lake Analytics instance, which I already created. Oh, sorry. Which I already created is this one. And if I go over here, I can see that there's a default data source. Why is this? Every Data Lake Analytics unit needs a Data Lake Store account because it needs to store certain metadata about the service. And this is C# assemblies, or also the history about jobs, files, basically just the data store for your Data Lake Analytics. But we can also add another data source which allows us to use it in the U-SQL scripts. So if you want to use one in your U-SQL scripts, you need to add it here first, because otherwise it will fail. So we will add one by account name, and I just select the Data Lake, the StackExchange Data Lake Store, the one we saw. So I click Add, and now I can add this to my U-SQL scripts. So this guy is ready to go. And now we go to Visual Studio. Sorry, I forgot to show you the data set. So as you can see, this is an XML. For big data processing, XMLs are not really nice. Why? Because they have a certain structure. If I want to tear this file apart into multiple pieces to separate it across multiple nodes, this is actually a problem. Why? Because if I separate it into two pieces, my root node will be not in the same file as the ending root node. So basically, the first step in the aggregation is also transformation to a CSV file. So what we will do is we will write a custom extractor, because this is not supported by default. And then in that custom extractor, we will also say each file should be processed in the same format so that we can keep the whole structure of the XML. So here it's just a root node with all rows in it. But imagine if you have multiple substructures, that would also be broken. So basically what you need to do is you just need to just pull in a NuGet package, which is this guy, and you basically just implement the I extractor, and then you need to implement this extract method. And also notice over here, this is the flag telling Data Lake Analytics not to separate the file into multiple pieces because of the structure. This is actually a very funny one to find, so don't ask me how I know. So basically what you get in is just an input and an output, where we will just use an XML reader from .NET, where we load the stream of the input, and then we just do the XML parsing like we do in .NET, where we check, okay, if it's a row, then we know it's an entry for our output, and then we just loop over all the over the schema, and then we interpret the data. Okay, and then if it's null, then we just set the default value, because we need to have a default for each row, because otherwise our CSV is messed up. And then we check if it's a string, then we simplify it. Why do we do this? Because, where is it? Okay, we remove these because they don't like it, and certainly if it's a CSV that uses a comma, I don't want to use a comma in the data fields. I just change it to a, I don't know the English word, a comma with a dot on top of it. Yeah, semicolon, thank you. Okay, so basically we just clean the data a bit, and there's a byte boundary, so if it exceeds that, we just adapt that, and then we just say, okay, output, this is the name of the column and this is the value. If it's not a string, for example, an int, so here this column basically refers to the script where we will define the schema of the file, and then we just convert it to the value. Okay, and then we just return every row. Okay. If you want to play with this later on, it will be available, so I'm going pretty quick, but you will be able to do this afterwards. So, for example, this guy, if we want to aggregate all the users, which we will need for the demo, we start first with referencing to the assembly, which contains our custom extractor, which will be deployed in Data Lake Analytics. And there we say, okay, go to this Data Lake store account, where I can use these kinds of placeholders to loop over all the folders. Instead of having to add all of them, I just say, okay, let's call this dump name, and I can use this in my output as well, which is actually very nice. And then the source is the name of the website in my folder structure, which will also be included in the result set. And then I just refer to my custom extractor and capture this in a variable, and then I just output this one to a CSV file on my default Data Lake store. So that's why it's a shorthand notation, while over here I need to prefix the whole name. That's the difference. Okay. For the sake of the demo, we will not use the 3 data sets. Why? Because we will have a lot of duplicate users, because it's the same data but just a slice of 6 months added to this. So I have another one where I don't use the dump name but basically fix the June data set. But before we want to do this, we need to deploy our custom code first. So there's one option where you can run a U-SQL script where you say, okay, in database master, drop the old version first, because this is the new version, where we do create assembly and give it a name. And then we can point to a Data Lake store folder where we uploaded the DLL. An alternative is we go to Visual Studio and we just say, okay, register this DLL, and then I don't need to upload it. Come on, wake up. There it is. So I choose my Data Lake store, Data Lake Analytics account, sorry, and I use my user. Then it will ask me which database. So for the sake of the demo, I'll just use the master database, but if you want to use another one, you select another one here. And then I give it a name. If there was already another one, I could select this checkbox to override it, and then I choose the amount of data lakes units I want to use for this. But because it's just registering a DLL, I could provision 5, but it will only use 1. So then I hit submit, and let's hope the internet is very nice. Okay. So now what you can see on the left is actually the flow of the job. So first it's preparing it. What is it doing now? So it's compiling the script, checking if you're using custom code. Well, is that custom code deployed on the Data Lake Analytics account? You're referring to a certain folder. Do I know that data source, etc.? So once everything is compiled, it will queue the job for processing. Then it will be run, and then it's finalized. So by now, you see it's finalized, but it's only registering the DLL, so I don't have a job graph. What you can also see over here is the duration of the compilation, of how long it queued. Well, basically not. And then how long it took to run it. So only 3 seconds. But also over here, you can see again the parallelism, which is the analytics units, and then the priority. So the priority is how higher the amount, the less high it's in priority, actually. So priority 1 is the most important one. Okay, so now my custom code is there. Now I can run the aggregate script. So I can just select NDC Sydney. I can submit it. So now it's compiling that script. Actually, let me go to the Data Explorer to see the results. So now, in the Data Explorer, we see that we have a reference data folder, which contains a file we'll use during the business logic, let's say. Then we have the catalog and the system folder, which is the metadata for the service itself. This is only because this is the default data store. And then once the job is done, see, now it's running. I use parallelism 5, which was not a good idea. I should have used more. Okay. Okay, so now you see we have 328 stages and 328 vertices. So like I mentioned, vertices are smaller pieces of data sets, but because in my custom extractor I said I want to use atomic processing, it just uses 1 for each file. So basically each stage is 1 file. And now if I do expand all, yeah, you can see this. Why? Because we have all of these files, but if I zoom in, yeah, you can see that there's just one aggregate shape to aggregate all these files, and then it's outputting it to my user's CSV. Okay, this will take a while. Let's cancel it and provision more analytics units. Come on. Oh, yeah, okay. So it's cancelled. Let's try again. Okay, in the meantime, let's go through the next script. So we don't need this one anymore. No, this one not. Okay. So after that, we will create a small script to... So what will we do? We will take all the users in the aggregated file, check their profile, there's a location in there, and then we will check doesn't match the name of the country. So it needs to exactly match it for the sake of the demo, but in reality you would check, does it match the country and the country, or if it has more information in the field. For example, I live in Belgium, it should also detect Belgium and link it to Belgium. But for the sake of the demo, we won't do this. But that means we need to have some reference data that contains all the files in the all the countries in the world. And for that, there's a data set based on the ISO 3166 that contains all the countries in the world, where I also added a field friendly name. Why? Because in that standard, the official name for the USA and the UK are, hold on a second, United States of America, where I added United States, and then for the UK, United Kingdom of Great Britain and Northern Ireland. So there I just added United Kingdom as well, and basically I should also add Ireland. But okay, because I don't think a lot of people use that naming when they need to provide their location. So we will use these friendly names, map it to the user location. If we have a match, we will add it to that bucket. If we can't resolve the country, we will add it to the not found bucket. And if they don't specify it, we add it to the not specified bucket. Okay? Then we can create a certain visualization, and then we also do averages and certain things. So for that, we first need to, again, extract all the aggregated users from our data set. So it's basically the output of the previous job. And then we also load all the countries from our reference data. And as you can see, it's also on Data Lake store in this folder with his name, etc. And that's a CSV. So then we have two variables containing our data sets, and we can perform some logic on top of it. But I'll first have a look. Oh boy. Yeah. Moving on. So because it's case sensitive to match the fields, I also created a cleansing method, let's say, where I just add the locations and I just lowercase everything, so I can match the friendly name with the location in a lowercase. I could also use that existing C# assembly, but each script also has a code behind. So if I go to the code behind of my script, you can see I have a class with a small method in here which just takes a string. If it's null or white space, I just remove it. I just give it back because I'm not interested. If it isn't, then I move all the trailing and just remove all the spaces at the beginning or the end, and then I just do a to lower. So I'm sure that the data is the same before we match it. I do this for all the users, and I do it only for the location because I only need it there. And then for the countries, I do it for the name and the friendly name, the region and the subregion, while actually I just need the friendly name, but whatever. Okay, so my data set is clean. Note that I cleaned the data sets which I already extracted. So I'm not cleaning it on the persisted data. I'm doing it in the, let's call it in-memory data. Okay, so I'm not adapting the original data. And then I can just use SQL-like language with C#, where over here I'm using inline C#. If there's no region, if the region is null, then I add not applicable, and otherwise I use the region. I do a count, I use an average. Well, average is not the best fit, but okay. And then I just do a join on both the users and the countries, where the location and the friendly name are the same. And I group by region, subregion, and name. So here I'm basically creating an overview of all the countries per region, per subregion, to determine how many users live in Australia, for example, and what the average reputation is. Okay, and then the second one is where I divide them in the buckets. So this one will include all the users. Then this one, so I don't filter over here. Then the ones that are not found, I do a left join, where I also check if the friendly name is null and the location is different from an empty string, to make sure that I don't match the not specified ones as well, which I have over here, which I also union, by the way. And here I also have an inline C# expression, and then a union with all the found users where they are actually the same. So no rocket science, but also shows you that I can just write a small script on top of the big data set. And then I just output it to 2 CSVs. Problem is I need this guy to finish. Okay, it's already there. So then I just, that was not smart. If you just click submit, it uses the previous, yeah, S20, should be fine. So now it's running that one. And over here, so now this one is done, but you can see that you can just, I need to load the profile first. And then I can, come on. And then I can just replay the whole processing. So now it's just, yeah, all of these boxes, but on the next job I'll show it as well, where you can see, okay, this step was taking a lot of processing, and then you can see, okay, this is because we're aggregating after blah, 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 and then you can see where the bottlenecks are in your script. Also, I mentioned resources. I can see how many of the allocated analytics units that were used. So we can see the most used ones were 20. So actually I over provisioned 5 analytics units. If I schedule this kind of job in the future, I can only use 20 because we can save money with that, which is actually important. And then you have this modeler. So let's say I had 10 units. It shows you a prediction. It's not certain that you will get this result, but that's what they think will be the outcome. So this is actually very interesting if you need to model your script to optimize with the cost. Okay, so let's see where this one is. It's refreshing. Okay, we're already at half, and you can see that it's already a more fancy graph. Well, I don't need to know how to model this. I just need to write the script. They do the logic for me. Don't need to provision any clusters. Just write the business logic and run it. Okay. Okay, it's finished. And now you can see that on the left side how many bytes it read and how many were written, and also that we separated the one big aggregated user file across 37 vertices. Okay. And if I use this one, I need to load the profile first. But instead of progress, you also have these others to view the processing. So if I use computation time, for example, you can now see where the bottlenecks are. So extracting. Really helpful if you need to troubleshoot certain things. And then if we go back to the resource usage, you see I provisioned 20. Well, actually, I could have used 10 or less. See, 12 would have been perfect. But that means if we go back to our data store, we have the aggregated data folder where we have this aggregated users. So it's only 3.66 gigabytes. But if I would have run on all the data sets or used other files, it would be bigger because the users is actually pretty small. But here I can also have a small overview. So on the left was the source, so the name of the of the website, and you can see that they have these test users across the same all the websites, which all live on the server farm. So yeah, here you can get a. I won't download the file, but that's how you can also check the result of your data set. And then our output of the reports is now over here. And I can just use Power BI. So I'll just quickly, first I need the URI. And then I can just go over here, select Data Lake Store. Actually need to speed up a bit. And then you need to authenticate. Why? Because it's again using Azure AD for the security to know if I have permissions to view this. Okay, and then I can connect to the Data Lake Store account. So now it gives me this. So basically it's just a folder structure, which is not the data set I want. I can edit it. And it goes to this modeler. Come on. Australian internet. Okay, I'll let it load a while. I'll proceed with the slides first. Okay, so operations, which is important. Data Lake Store, like I mentioned, we have the graphs for storage, read, write, ingress, egress, but we don't have metrics and we don't have alerts, which can be a problem. And then we also have audit and request logs, which can be interesting, but yeah, not crucial for certain scenarios. And then we have Data Lake Analytics, where we also have the graphs, where we can see the amount of failed jobs, succeeded jobs, cancelled jobs, etc., and the evolution of the used analytics unit time. And we also have metrics of those, but we don't have alerts on it, which is not perfect in my opinion, because I want to have an alert if a job fails. For example, if I schedule certain jobs on a daily basis, I don't want to log in and check every morning. So tooling, I showed Visual Studio, where you have also a store explorer, where you can just connect to your store and browse it over there, so you don't need to log in the portal. And I also showed you the job visualizer, where you can just troubleshoot your jobs. And to a certain extent, you can do the same in the portal, but the Visual Studio tooling provides more richer capabilities. If you like Visual Studio Code, you can also use it to run the unit test on the extensibility, for example, which I didn't show you, or just use the local execution, because yeah, if you want to save money, you'd want to test your scripts first locally, which you can actually also do in plain Visual Studio. Then integration with other services, the most important one is Data Factory, where you can create these pipelines and schedule them as well. So one scenario would be that you copy data over into Data Lake, and then after that it triggers a script to run on top of Data Lake Store, does something with the output, etc. You can also use Azure Data Catalog to annotate your data sets, to kind of document all the data sets you have, so that you are certain that it's not becoming a data swamp. And then let's see how Power BI is doing. Not good. Okay. So I want to have my report, so I go to this table and let's use the location. And then I can just use all this information. So, oh, that's not supposed to happen. Okay, I am not interested for all the for all the results because we know that, but let's use this data set. Normally you would give them nice names, but for the sake of the time, I'll skip that. I'll also include an example in the GitHub repo so you can see how you can just use them. But let's say I want to use a map, which is over here. And then I know by heart that this is the location. I should have used the names. Okay, and then shit. This should be the location, and then no, I'm using the wrong data set. No. Go back. Continue. Yeah, this is the one I want. Skip the names again, because I like living on the edge. Okay, so location, here we go. No. Here we go. And then I know this is the continent, and then this is the subcontinent. Yeah, oh, actually, wrong field. This is the amount of total users, so I can adapt the size or use the reputation, and then I can add some tooltips. Okay, so if I go hover over the US, really bad names, where maximum reputation is 612 and the maximum views is 35. You can see that in India there's a lot more people using StackExchange, for example. Okay, I'll just leave the Power BI part for now, but if you're interested, I can show you after the session. If you want to know more about Azure Data Lake, they are preparing best practices for now. It's not public yet, but if you want, contact me, then you can get a preview of this. This is a book I can really recommend by Soiner Tejada about all the things about data analytics and Azure. He gives you a whole overview of the data stores you can use, the kinds of analytics you can use, how you can visualize it, prepare it, etc. Really nice one. Then they also have a Microsoft Virtual Academy introducing Azure Data Lake. They have a GitHub repo with all the release notes and the announcements and the U-SQL documentation. Okay, and then a small summary. Yeah, big data is not a hype anymore, but that's obvious because data is the new currency. If you Data Lake Store, you can use to analyze today and tomorrow because it's data lake, not a data warehouse. So you're not throwing away your valuable data. And beware of the data swamps. You don't want to have that. And then data lake analytics. You don't have the cluster management, which you also don't have for store, but you can just write your scripts and give it. So in a certain sense, it's also serverless, to include a buzzword. I can reuse my existing skills to write these scripts. I don't need to learn Hive or whatsoever. Don't need to learn Java because I don't want to do that. And I just pay for what I use. So I don't need to pay for all the VMs of the cluster as well. I just pay for the compute. So my advice would be if you want to use big data in Azure and you're a C# or SQL developer, use Data Lake Store and Analytics. Thank you.